Alright, you guys, the last problem that we have today is just going to be an application problem that puts together the information we've seen from different types of equation writing problems. For this example, it says Mrs. Alt is visiting Rhode Island this week. In 2010, there were 30 daily sightings of bottlenose dolphins in Narragansett Bay, Rhode Island. In 2018, there were 60 daily sightings. So one of the things that we really want to try and work on as we do equations with slopes or equations with lines is to recognize what are the key pieces of information that we need and what's just kind of extra words or extra verbiage in the problem. So what we really want to identify is what are the two pieces of quantitative data that we have, and then how do we work with them. The faster we can do that, the less it feels like we're just spending our time reading lots of extra information, and the faster we can get through the calculations. So here it says in 2010, there were 30 daily sightings. In 2018, there were 60 daily sightings. So what that really tells us is we have two ordered pairs, one that's 2010 30 and one that's 2018 60. So we have those two ordered pairs. Anytime we have ordered pairs, we can calculate a slope, and then we can also calculate the equation for a line. We're just working with numerical data at this point. This represents a year, and this represents a sighting. So as long as we keep the application in mind as we go through, we can treat it like we would any of the previous problems we've seen today. So if we're trying to come up with an equation and we just have two ordered pairs, the first thing that we want to identify is our slope. So to find our slope, we're just going to subtract our two y values, subtract our two x values. So up top here, I'll do 60 minus 30, so I don't have any negatives. And then on the bottom, I'll do 2018 minus 2010. So that's going to become 30 up top and 8 down below. Now I can leave that as a fraction if I want to, or what I could identify is if I do 30 divided by 8, I'm just going to get an easy decimal to work with, 3.75. So I'm going to go ahead and convert it to that decimal value. Now I have a slope. I can pick either one of these ordered pairs to work with and put it into point slope form. So in point slope form, I'm just going to take a y and subtract one of my y values. So in this case, 30. And then I'll take my slope, 3.75, and I'll do x minus one of my x values. So in this case, 2010. Then I just want to go ahead and rearrange that into my slope-intercept form, because it's going to be easier to graph and it's going to be easier to plug things into. So here, y minus 30 equals, I'm going to distribute that 3.75. So I'll have 3.75x minus, let's multiply that 3.75 by 2010, and we get 7,537.5. So then I just need to add over that 30. So when I have negative 7,537.5 on one side, and I add over that 30, that means I have negative 7,507. So 3.75x minus 7,507.5. So that's my equation that describes the number of dolphin sightings over time. So then in part B, it asks us to use the equation to predict the number of dolphins that will be seen in 2019. So my x values are the years, y values are the sightings. So all I need to do is plug in for x. So I've got y equals 3.75 times 2019 minus 7,507.5. So let's plug that into our calculator. 3.75 times 2019 minus 7,507.5. And we end up with 63.75 sightings. Now in general, when you're working with application problems, you want to think about what context you're reporting your answers back in. You can't see 0.75 or 3/4 of a dolphin, so what I would recommend doing if I come across an answer like this is rounding to 74, because that's what makes most sense in the context of the problem. Now a couple more key pieces of information we want to note about these kinds of problems is that we can work with them either if we're given x values or if we're given y values. So here we're asked to predict the number of dolphins given the time. So we plug in for x and we solve for y. We also could be asked to find the year given the number of dolphins. In that case, we would plug the number of dolphins in for y, solve for x the year. Another thing that's good to be aware of is you can make intelligent decisions about what kinds of numbers to work with based off of how easy it is to do the calculation. So here, notice that I did my year as 2010, my sightings is 30, and then my year is 2018, my sightings is 60. What I also could have decided is that in 2010 is when we began measuring. In that case, I could change this ordered pair and call it 0, 30, and this ordered pair, which is 8 years later, 8, 60. What that means is I would get a different equation, and I would want to clearly identify then that x is number of years after 2010, so that when I go to plug in for b, I would plug in 9, because that's 9 years after 2010, instead of 2019. I would still end up with this same final answer, but it might be a little less bulky to work with if I'm not having to multiply things by thousands as I go along. So consider when you're writing linear application problems, sometimes there's more than one correct way to write the line as long as your variables are clearly defined, and you'll still end up with the same answers. So we'll see that in practice, kind of depending on how large the numbers are, what the right way to define those terms will be. So the rest of time today in class, you have to work on your section 2.4 homework, and that's posted on the website as well. Now, tomorrow in class, you're going to be practicing a lot of different linear concepts, and you'll see that through some ACT practice. On Wednesday, we're going to get into a little bit of review and then a new section. On Thursday, we'll get into another new section, but Friday will be all practice with real-world problems. So if you have any major questions from this section, we'll have lots of time to talk about it on Friday. Otherwise, please feel free to send me an email with any of your questions to this point. Thank you guys, and I'll see you on Wednesday.